Welcome everybody, this is video number 77. This one's going to be plate tectonics and this is part 1 and we're going to welcome back Miss Barber again. So this is Turser Wilson, and actually you guys can YouTube him and actually see actual video of him on YouTube, although it's really kind of grainy and kind of a little bit yucky and he talks very, very slow. But he was the guy that actually came up with the theory of plate tectonics. He's the first guy that kind of busted up the crust into plates, and these are a couple of pictures of him. He was Canadian, by the way.
He was a lot younger when he came up with that theory, right?
Yeah, oh yeah,
okay.
Yeah. He wasn't the old guy you see there.
Because I remember seeing pictures of him really young.
Yeah. But he's dead now. He's in my dead dude club, but not my old dead dude club. So he's not like Wegner and Hess, who are in my old dead dude club. Old. They're just in my recent dead dude club. Oh. Sorry. All right, you want to talk about plates? Come on, let's talk about plates.
Throw me on the spot here. The lithosphere is like the crust. Right? And that's broken up into plates, which is just different sections of the crust.
Exactly.
There's 7 major plates. Why does it say minor plates down there?
There are like a bazillion minor plates.
Like little tiny.
Yeah,
little
like there's actually some you can actually see here that says, I don't know how you pronounce this, the Cocos plate. I'm not even sure if I'm saying that right.
But I'm guessing tiny isn't really tiny.
Yeah,
it's just small
tiny
compared to the
yeah, very good. Yep, and I wasn't going to list all those. So, 7 plate names. I'll do one, you do one?
Sure.
Okay, number 1, the African plate.
Number 2, the Antarctic plate.
And it's going to be the one way down the bottom, right? Number 3, the Eurasian plate. Been there. Very nice place. Very nice place.
Oh, really?
Yeah, loved it.
Number 4, the Indo-Australian plate.
Yeah, I've
Australia.
Lots of plane rides.
Is Australia on that?
We live in number 5, the North American plate.
Number 6, the Pacific plate.
Nice and
warm there. Which I'm guessing is where the Ring of Fire is.
Yes, where the Ring of Fire is. Yep. And then we have the South American plate.
A view from space reveals Earth's continents as we know them today. There are 7 in total, but some are separated by a political divide rather than a geographical one. Africa-Eurasia is a supercontinent comprising of Africa, Europe, and Asia. It stretches from the Siberian Plateau in Russia to the Cape of Good Hope in South Africa. A spectacular route across 3 continents, incorporating dramatic climate change, vivid scenery, and diverse cultures. However, Africa-Eurasia isn't the only supercontinent on the planet. Because the Panama Isthmus links North and South America together, they too can be thought of as one vast landmass.
The solid layer of rock, the crust, on which the land and ocean sits, is broken up into a series of vast slabs that geologists call tectonic plates. It's these plates that are moving, grinding past each other, and triggering earthquakes. The underwater ridges and trenches sit on the boundaries between tectonic plates. The East Pacific Ridge and the Marianas Trench lie on opposite edges of the Pacific Plate.
So let's talk about what the plates actually include. And Mrs. Barber actually alluded to this already. It actually includes the crust, whether it's oceanic or continental, and it actually includes a little bit a part of the lithosphere. Not the whole thing, but just part of it. All right, you want to do plate movement?
Okay, plate movement. 1 to 24 centimeters per year.
Yep.
So that's not very much.
No, it's not like you're going to be on there going, whoa, the plates are moving. Not so much.
And they figured that out by measuring it with GPS. All the plates have motion, so they're all moving a little bit. They can collide, they can crash, they can pull apart. Pull apart.
Oh, right, pull apart. My bad. My bad.
And they can slide past each other and grind.
Yep, very good. So, how fast are the plates moving? Because I know you guys are going to ask me this. Are they being the tortoise or the hare here? So, the Arctic Ridge is the slowest. It does 2.5 centimeters per year. And the East Pacific Ridge is the fastest at 15 centimeters per year. Pretty cool, huh?
Very cool.
I had to look those up. Google.
Didn't the last slide say, though, it was 1 to 24?
Yeah, I think that's an average across the board. So over the years, it changes. It's not always the same. Yeah. So the 2 things we do to track our plate movements is we have stuff on the ground here, and we also have about 20 satellites in orbit that are dedicated to this. So if you go on Google, you can actually see real-time video on some of them. It's actually pretty
where
cool.
they are?
Yeah.
That's neat.
Yeah.
Force driving plate movement.
That's right.
So what is causing the plates to move?
Right.
Okay. The Earth's mantle, which is, you remember, you taught this already, right?
I did. They know it.
Which is...
They better know it.
Molten, like it's not quite liquid, but it's
Right.
not quite a solid.
Right.
Okay. Under the Earth's crust.
Mhm.
And there's convection currents in the mantle.
Yes.
They know what convection currents
They
are?
do. I just taught them today how to draw them accurately. See, they're
Ooh.
still on the board over
Oh,
there.
very nice.
Yes,
So
yep.
there's the convection currents moving in the mantle,
Mhm.
and that causes the plates to move.
That's right. So when in doubt, and remember poor Wegener, when they did the to Wegener, it's because he didn't know what that force was. The force is the convection currents. When in doubt, that's the right answer in our science, okay?